Okay, so we are taking example of the context-free grammar, context-free language. So, we are saying that if a language is a context-free language or not. So, basically we have given a terminals, or it could be 0 1, it could be A B, it could be A B C 0 1 2. So, anything. So, we have input alphabet, which is also called terminal in the sense of context free grammar, and we have a language L, which is a subset of sigma star, which is consists of the strings of coming from the alphabet of sigma. And then we know this, we call this is a context free grammar, context free language if there exists a grammar G, T is here P S, S is the start variable such that this S is so L is nothing but L G is the language generated by G, which is the set of all strings of these terminals or the alphabets, such that this is derivable from S by the productions. Now, if this L is same as this, if the any string is in L, we can derive it from S, then it is called a context free grammar. Okay. So, there may be more grammar to generate a context free language. So, we will take an example of that. We will take an example of that. So, find a context free grammar for all binary string with an even number of zeros. Even number of zeros. Okay. So, we just take a string of 0 1. So, here T is, I mean sigma is 0 1. Input alphabet is binary string, binary alphabet. So, we take a string and we count the number of zeros. So, number of zeros must be even. Say for example, if this is the language L, so L consists of also this is 0 0 even number of zeros, say epsilon we can say no zeros, 0 number of zeros, then 0 1 0 1 0 0 like this. So, even 4 zeros, any position of this like this. So, even number of zeros. So, that is our L. So, now we want to see whether this L is a context free language or not. So, that means we can you construct a grammar which can generate this L. Okay. So, so basically we want to decompose the string. The string, we take a string which is even number of zeros. So, how to decompose it? So, so this is belongs to L. So, where the W has even number of zeros. Now, how to decompose W? If we know, then we can get the grammar, we can get the production. How to decompose W? Okay, so first one way is first symbol start with 1, first symbol start with 1 and followed by even number of zeros, followed by even number of zeros. And second one is first symbol start with 0, then followed by odd number of zeros. So, first symbol start with 0. Since we have already have 1 0, then the remaining will be have odd number of zeros. 0, then go to the next 0, then go to the next 0 followed by even number of zeros. Even number of zeros. Okay. So, if we can see this decompose, then we can write the, we can construct the gamma. How? So, so let us try to construct the gamma based on these two decompose. So, we have this grammar G. So, let us have only one symbol, one variable, and then we have 0 1 as the terminal or the alphabet, and the production rule and S. So, what is the production rule? Production rule is like this. So, S is going to, so starting with 1 S or 0, then A 0 S epsilon. So, this is the first case, because S is the, S should generate the even number of zeros. So, if we have a starting with 1, then still S has to generate the even number of zeros. Now, if we have a 0, then we will have to go for the next 0. So, this A is going to 1 A or epsilon. or epsilon. So, this is our P, the productions. Okay. So, this is our P. So, now this by this decomposition we can get the production. So, that is the trick. So, now we can verify this. This is giving us the same language. So, we can check whether say we take any arbitrary string 1 0 1 0 0 0. So, this is having how many? This is having 1 2 3 4 even number of zeros. So, we want to check whether this is generating by this language. So, how to check that? So, we start with S, we derive. So, we have a 1 over here. So, we need to follow, we need to take this, then we can take this S to be this rule, because we already have a 0. So, 1 0 A 0 S. Now, this A must go to 1 A, because this 1 is there. So, 1 0 1 A 0 S. Okay. Now, this there is no more 1 over here. So, now this A must go to epsilon. So, this is 1 0 1 epsilon 0 S. So, now how many zeros we have after 1? So, we have 1 0. So, we still need to have 2 more zeros. So, we will take help of this one again. So, 1 0 1 0 0 A 0 S. So, we already have 3 zeros. Now, we can make this is epsilon 1 0 1 0 0 epsilon 0, and in the next step we can make S also epsilon. So, this is nothing but 1 0 1 0 0 0, this one. So, this can be derived from S. How many steps? 1 2 3 4 5 6 7 8 actually. So, this is 8, but we can make it star, like after few derivation we can reach to that string. So, this is accepted. Now, this way we can verify that any such string is accepted by this, where even number of zeros. Now, we can have another grammar for this. Okay, so, we can have another grammar for this. So, for that we need to decompose like this. Yeah. So, the idea is, so this L is the set of all W such that W has even number of zeros. Okay. Now, if you take a W from this, now earlier we decompose, now we can decompose in another way like this. So, first we generate a first symbol is 0, then followed by odd number of zeros, followed by odd number of zeros, like this. So, we can have like this. So, S is going to 1 S 0 T, this is this one, or epsilon, this is this one, or second one is it can start with it can start with symbol 1 and then followed by again even number of zeros, and then T is going to 1 T or 0 S. Okay. So, let me just write this. So, let me just write this grammar. So, our G1, the grammar 1 is earlier grammar. So, V is same, only one symbol, this is 0 1, P1 and S is. So, what is P1? P1 is the earlier one was S is going to 1 S or A 0 S or epsilon, and A is going to 1 A or epsilon. So, this is our 1 G, and another G2 is, so we take some S 0 1 P2S, or we can change the S also, does not matter. So, what is P2? P2 is S is going to 1 S 0 T or epsilon, and T is going to, guess the rule, 1 T or 0 S. Okay. If we have a 0, then we must have a S, because that will, I mean, we need to have even number of zeros. So, these two are different grammar, but they are accepting the same language. So, L of G1 is equal to L is equal to L of G2. So, this is one example where we can have more than one grammar for a given language. Okay. So, now we take another example where we will come to know why this is called the context free, why this is called context free grammar or context free language. I mean, so to understand that, let us take one more example. So, we are looking for a grammar, context free grammar that generate sentences as composed by composed of noun and verb phrases. Okay. So, we are looking for a grammar which is give us this English sentence which are composed by noun and verbs. So, like the bird sings the song, like this. Okay. So, how to do that? So, let us draw a so S is going to say noun phrase, then verb phrase. Noun phrase where it can go the and noun, and the verb phrase verb then the noun phrase, and the verb is say there are say two verbs sings and eats. So, sings or eats, and there are say nouns are say cat, song and bird. Cat, song and bird. Okay. So, now we will see the what are the grammar, what are the string we can accept, we can generate out of this grammar. Okay. So, this is a grammar for this sentence. I mean the sentence as composed of nouns and verb phrases. So, this is noun phrase, this is verb phrase. So, what is the G is? So, this is our P. G is V T V T P S. What is V? V here is S, noun phrase, verb phrase, then the verb and the noun. Okay. And what is T? T is the these terminals like sings, eats, then cat, song, birds. This is our T. Okay. Da is also there. And S is the starting string. Now, we want to get some we want to get some string of terminals which is generating by this grammar. So, let us try that. Okay. So, what we will do? We start with S. We take this, S is only going to NP VP, then say NP is going to this rule the N VP, and say VP is going to VP is going to VNP again. VP is going to the N. N is say N can go any one of this. So, I can write bird then VP. So, V p is going to now V n p. So, the but V n p. So, V can again go to either one of this. So, the but sings and the n p. N p is the n again go to say song. Okay. So, this is derived from, this is a sentential of this. Sentential means which can derive from alpha. Alpha is called a sentential, which is a V cross terminal if alpha is derived from S by the rule of by the production in G. Okay. So, this is a sentential, that means this is generating from this S. So, S is generating this. So, S. So, the but sing the song. So, this is a string which is accepting, which is generating by this language. Okay. Now, we will try to get another string. We will try to get another string out of this. Okay. So, so we start with S. So, from S we can go to N p V p, there is no other option, N p V p, and from N p we can go to the N V p. So, V p also we can go to V n p. Now, from here we can go N can go to any one of this. So, N can go to song. So, the song, and V can go to any one of this its, and N p again go to the N. So, now this N again go to any one of this. So, the song, its, the N can go to cat. So, this is the terminals, this is the, there is no variables there. So, this is a string generating by this grammar, and it has no meaning, the song ate the cat. So, that is why it is called context free. We just follow the rules and we reach, we do not, I mean it may not get a meaningful text. So, we just follow the rules. So, that is the sense that this things is called context free. So, all the legal sense. So, this is so that means S is generating this also, and S is, this gamma is generating this, and this gamma is generating this also. The song eats the cat. Okay. So, it has no meaning, but it is a legal sentence. So, we can get all the, so all the legal sentence are generated, not that just those has a meaningful, that is why it is called context free. All legal means grammatically, I mean English text, legal, sorry, L-E-E-L. All legal sentences are generated or can be generated, not just those that are meaningful. So, that is why it is called context free. We just follow the rule, we just follow the grammar and we end up with a all the possible sentences which it can form legal sentence. All the few sentence has no meaning, like this has no meaning in the English text. The song is the cat. Okay. So, this is the sense, it is called context free. So, yeah, so let us take one more example. Okay, so just a quick example. Suppose we have a grammar like this. So, we have two variable S and C, and the alphabet or the terminals are A B, and P is the production and S. So, P consists of, say, S is going to A C A, or S is going to S C A, and C is going to where? C is going to A C A or B. Okay. Now, can you tell me what is the language corresponding to this? What is L of G? Now, we can exercise this, and my claim is L of G will be A to the power n B A to the power n is greater than that. Okay, now from S we have to start with this. So, from S we can go to C, no doubt there is only one options. Now, from C, this is capital C. From C, if we go to B, there is two options. If you go to B, then it will give us A B A, or if we again apply this, then it is capital C. Then it will be A C A. So, again if we apply this one B, then it will give us A square B A square. Otherwise, if we apply again this one, so eventually it will be of this form. Okay. So, the A to the power n, this will be belongs to this. Again, if we take a W which is generating by this grammar, we can prove that W will be of this form. Thank you.